Okay, today is the start of kind of a major topic in computer science that we're going to be using a lot for the rest of the year. We're starting to wind down, though. There's not too much left. We got this, and I can think of one other big topic after this, but that's about it. So let's get started. Today we're going to do something called matrices. So you're going to need your own paper. So hopefully you grab some paper already. But when you have a sheet, you can just call the title of this matrices. Okay, now what a matrix is, some of you may have heard about these in math before. If you're in pre-calc, you've probably done these, or you will be doing them shortly. But a matrix is basically a grid. So let me kind of show you an example of something that would be represented by a matrix. It's a grid of numbers usually. It doesn't have to be, I guess it could be anything. But let's say we've got 3, 2, 5, 6, 1, 5, 7, 9, and 4, 8, 0, 3. That's a matrix. And this matrix has 3 rows and 4 columns. So like, hopefully it makes sense that as we go across, these are all rows. So rows always go across and columns go down. So we've got a column here, column there, and a column there. So we would say that the size of this matrix, we always do rows by columns. That's how you know which one you're talking about. Rows come first. So this is a 3 by 4 matrix because there's 3 rows and 4 columns. Okay. So how we declare a matrix, meaning how you make a matrix, is you have to say the type. So let's say I want to make an integer matrix because that's usually what we're going to be doing. And let's say, remember when you were making an array, how'd you make an array? It was int bracket bracket, right? So for a matrix, since there's 2 dimensions, it's int bracket 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 bracket. And then you would name it whatever you wanted to. I'm going to call mine M. And just like an array, you then write new int, and you give the size. And again, it's always rows by columns. So I'm not going to do a 3 by 4. Let's make a different one. Let's do a 4 by 5 this time. So 4 rows by 5 columns. So this one isn't related to the example that I just wrote up top. Okay, but remember that the first thing is always the rows. The second thing is always the columns. Okay, so if I'm going to get technical for a second, M, just like with arrays, is a memory location. It's a pointer. It's pointing to a certain spot in the computer's memory that's storing all of this grid of numbers. And this is what you should be picturing when you see a 4 by 5 matrix. We've got 4 rows, 5 columns, and rows always go down, columns always go across. And also, just like arrays, if there's 4 rows, it's not 1, 2, 3, 4. It's 0, 1, 2, 3. So it's written to start with row 0. Same with columns. 0, 1, 2, 3, and 4. Okay? What a matrix is actually an array of arrays, if that makes sense. I'll try to draw a picture to show that a little bit more clear in a second. But essentially, it's an array of 4 elements. That's the number of rows. And each element holds another array with 5 elements in it. Those make up the columns. Since this one wasn't initialized to anything, and it's an integer array, by default, it's holding all zeros right now. So if I tried to access any individual spot, it would be 0. So I'll go ahead, if you haven't started already, fill in all the zeros to make our initial matrix. Okay, so that's how you make it. Now it's going to be helpful for us to figure out, given a matrix, how many rows and how many columns it has. So here's how to find the number of rows. It's similar to find the length of an array, because remember I just said a matrix is really just an array of arrays. So think of this matrix as an array of 4 other array elements. So the number of rows I could get by just saying, make a variable int num rows if I wanted to. And it's going to equal, just like an array, m.length with no double parentheses. Okay. How would I access the number of columns? Think about that for a second. So I need to make a variable to store it. So I'm going to say int num cols, just like I did with num rows. Any ideas? Okay, now remember it's an array of arrays. So the array at spot 0 has 5 columns. The array at spot 1 has 5 elements. The array at spot 2 has 5 elements. So to be safe, if I just say m bracket 0, I'm accessing the array at space 0. And since that's also an array, I can do dot length again. Now I usually do m bracket 0 because there's always got to be at least one row, otherwise we don't have a matrix at all. I'm just going to write or any valid row. So in this case, m bracket 1 dot length would give me 5, m bracket 2 dot length would give me 5, m bracket 3 dot length would give me 5. But again, to be safe, most of the time you'll see m bracket 0 because you can be sure that there is a first row. Okay. Any questions yet? Call me over if something doesn't make sense. All right, before we flip over to the next page, let's talk about accessing a spot of the matrix. It works again similar to arrays. Let's say I wanted to make, I don't know, let's turn this spot here into a 5. So I want to get at the element right here. That's at row 1, column 3. Luckily, it works kind of how you would expect it. You would just say m bracket 1 bracket 3 and set it equal to, in this case, 5. Okay, so similarly, how would I make, let's say, this spot equal to 10? Write down what you think it would be. Remember, rows always come first. So m bracket 3 column 2 equals 10. That's it. Okay. All right. I'm going to flip over to the other side. And we're already almost done with these notes. They aren't very long today. So here I go. Let's do another example. Let's say I'm going to make an integer array with 4 rows and 3 columns. So I would say int bracket, 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 bracket. It's not an integer array. It's an integer matrix. So let's call it m equals new int. And what did I say? 4 rows by 3 columns. Okay, so I'm going to draw it a little bit differently this time. You know what you can picture. You're picturing a grid that goes down 4 times and across 3 times. Again, to get technical, m is a pointer that's pointing to a memory location in the computer. And what it's pointing to is an array of 4 elements, 0, 1, 2, 3. Okay? Now, each of those elements, there's not just an integer at all these spots, there's an integer array at all those spots. So here, there's an integer array with 3 elements. Here, there's an integer array with 3 elements. Here, there's an integer array with 3 elements. Here there's an integer array with 3 elements. The outer array, that 0 through 4, are holding pointers to inner arrays. So like if I just did m bracket 0, you'd see one of those crazy looking weird memory locations. Something like that, because it's actually just a pointer that's going to something. You don't really have to worry about that, but that's what's happening. Okay? All right. Another way to view what's happening is make it think more like an actual matrix. Instead of saying 0, 1, 2, 3 going across, those really represent the rows. So in your head, if you picture that outer array is kind of a vertical one, then at space 0, there's a pointer to another array of 3 elements. And this has a pointer to a different array of 3 elements. And this has a pointer to still a different array of 3 elements. And finally, that has a pointer to a fourth array of 3 elements. So in the end, we've got exactly what we expected. We've got a grid with 4 rows and 3 columns. Okay, that's a matrix. And if I wanted to set one of the spots equal to 5, let's say I said m bracket 2 bracket 1 equals 5. M bracket 2, it'd find this pointer, and it would point to space 1 in that array and set it equal to 5. Make sense? Okay, so hopefully you get what a matrix is. Let's just do one example method for this video. I'm going to say write a method that creates a multiplication table. And remember what a multiplication table is. If you think back to like your 3rd or 4th grade classroom, there was probably one hanging on the wall somewhere where like if you went to a row and a column, 7 times 9 is 63, right? So it's like a matrix of values. So each element in the matrix is the product of its row and column. Okay. So if we're just going to create a matrix that's a multiplication table, I just have to go through all the rows, through all the columns, and each spot I want to set equal to the row times the columns. Like here's an example. So here's a mini matrix here. It's a 0, 1, 2, 3, 0, 1, 2, 3. We'd have 0 times 0, 0 times 1, 0 times 2, 0 times 3. 1 times 0, 1 times 1, 1 times 2, 1 times 3, 2 times 0, 2 times 1, 2 times 2, 2 times 3, 3 times 0, 3 times 1, 3 times 2, 3 times 3. Something like that is what my goal is. Okay, so all I'm doing is filling a matrix. So since that's all I'm doing, just like when I fill arrays, it's going to be a public void. And I'm going to call it public void mult table. And I'm going to give it some matrix. I'm not even going to tell you what the size is, but int bracket, 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 m. Okay? We need our pre and post conditions. Precondition is just an integer matrix. It can be any size. Okay? And post condition, what this method is supposed to do, fills the matrix as a multiplication table. All right. So to get to every element in a matrix, let's pause for a second and go back. If I want to reach every element in an array, what do I use? A for loop. I use a for loop starting at 0, going through the length of the array. Well, since a matrix is just an array of arrays, it's a two-dimensional array. So I have to still go through all the rows, but then I have to also, at each row, go through all the columns. So it's actually a for loop inside a for loop. So it's a double for loop. And that's what you're going to have most of the time when you're dealing with matrices. You usually want to start by going through all the rows. So int I equals 0. Remember how to get through all the rows? I is less than m dot length. I plus plus. Okay, so now at row 0, I want to go through all the columns at row 0. So I immediately do another for loop. And you can't use I again because I's already been used once. And you're inside the I for loop, so you can't create another I variable. We have to use a different variable like j. So int j equals 0. J is less than, how do I get the number of columns? Okay, well you could do m, like I did on the front of the notes, m bracket 0 dot length. We know there's a row 0, so it's safe to do that. J plus plus. Then I want to set each spot equal to the product of the row times the column. So m bracket I bracket j would be equal to what? Whatever the row is times whatever the column is. That's it. And the double for loop and the public void. Okay, now in the next video, which I would encourage you to start right now if there's more than 10 minutes left in the class that you're watching this in, the next video takes you through some multiple choice type questions involving matrices. So it's going to give you some more practice with seeing matrices and understanding how they work. That video is a little bit longer than this intro, so I would recommend starting it today. And then maybe pausing it at a certain point and continuing it in the next class or the next time you have a chance to watch it. Before I do that, let me just mention one thing. I said this could be any valid row. So another safe way to do, if I've got a double for loop, this is going to start I at row 0, and it's only going to go through all the valid rows. So you could also just say m bracket I dot length there if you wanted to. It's no better than what I did, m bracket 0, but you will see it written that way sometimes because that's also safe. If I'm using I is definitely a valid row because it has to meet the condition that it's less than the number of rows. So you'll see that sometimes too, just as a heads up. All right, that's the end of these notes. Go right on to the next video and have a great time.